Hey everyone, welcome back to Just Learn channel. Today we are diving into an interesting question involving permutation in group theory. Very difficult area, but we will understand by the end of the video. Today we have a question that we have to calc the sigma composite L, and we have two permutations here. First one is the sigma in the matrix form, and for the other one we have L, which in the cycle notation. Okay, so in cycle we start with the first one. In the cycle notation, cycles tell us which elements swapped with each other. The notation 1 2 means that L and 2 that L swaps 1 and 2, while 2 and 5 means that L, which is the permutation here, swaps 2 and 5. So we apply L. Here is what happened. I know you can be confused, but it's will get easier, don't worry. First we write the L in the matrix form. Every time you start with writing this 1 2 3 4 and 5 and so on. Okay, now we have that L is 1 and 2 and 5 in the cycle notation, so we need to write them in the matrix. Okay, what the cycle notation tells us that 1 is going to 2, okay, and 2 sorry guys for pausing here, sorry, and 2 is going to 5. Here in the cycle notation we don't have any 3 and 4. That means that is 3 is going to it herself, and 4 is going to 4, and 5 is going to 2. Sorry, 5 we ask ourselves here. 5 where it's going to 2. The next cycles group, cycle notations, 2 is going back to 1, so that's why we write 1 here. Here we have the L in the matrix form, but I will explain again. 1 is going to 2, that's why we write here first 2, okay, and for the next one 2 is going to 5, we write 5 here. We don't have 3 in our cycle notation, that's why we write 3 under itself, because it's going back to herself, so we don't need to have to write there. 4 it's going back to 4, and we need to find the 5. 5 is going to 2, 2 is going back to 1, that's why we write here 1. Okay, very good. Let's continue. Now when we have the L, we write here L equal with every time 1 2 3 4 5, we write like that. 1 is going to 2, 2 is going to 5, 3 is going to herself, and 4 also, 5 is going to 1. Okay, now we have to calc the sigma composite to L. It's equal. Before we started, also we write 1 2 3 4 5. Here we need to remember that we are finding sigma composite to L, which means applying sigma after L. So now we take each element from L and applying to sigma. So let's continue. Sigma composite with L, so that means the direction you take from L and the element you take from the sigma. I will tell you. First element we need to know it's 1. 1 under it's 2. We jump into the sigma. 2 is going to 1. So we write here 1. Now the next element that we need to search is 2. We jump to the L because we take the direction from L and the element from the sigma. 2 is going to 5. We jump here to the sigma. 5 is going to 4. So we write here is 4. 3 is going to 3. We jump to the sigma. 3 is going to 5. We write 5 here. Direction we take from the L and the element we take from the sigma. 4, we jump to the sigma. 4 is going to 3. 5, we have here 1. We jump to the 1. 1, it's under 2. So this is the answer. I know it's you may be confused about it, but think like that. The L is the direction. You take the element from the L, which tell you which element you take it from the sigma. Yes, this is the best explain I have ever heard. The L tells you the direction in the sigma, and you take from the sigma from the element and you write here. Thank you guys. This is our video today. See you in the next one.